now that we have done our density lab by graphing out the mass and the volume and seeing how the slope is constant for a given substance, we're going to actually go through the calculations to determine the density of a substance, but also its mass or volume based on the other objects or other properties that it has. So let's go ahead and jump right into it. First off, you guys should understand from discussion yesterday that density is just a description of the compactness of the matter. All right, and we can actually calculate this compactness of the matter using the very simple equation of the density is equal to the mass divided by the volume. We can rearrange that equation to solve for the mass or the volume as well. And these will be important. We'll go through example problems for each one of these. But let's talk about the units. Units are important. They describe how you're measuring a certain thing. So mass typically is measured in grams, or at least some form of grams, maybe milligrams or kilograms potentially. Volume is typically measured in milliliters, could be also liters, or in some other form, potentially kiloliters. And density is just a combination of those two. It's grams per milliliter, or potentially some other unit of mass over some other unit of volume. So let's go ahead and jump into a practice problem. Let's say we take a metal block, measure its mass to be 402 grams, and it also takes up 83 milliliters of space. We can determine the density of this metal using those equations, but I want to be very clear on the steps that I would like to see you guys going through. There are 4 steps that will help later on when we're back in person to show me what you're thinking as you are working through these problems, and if you're doing some wrong thinking, to help fix that immediately. So first off, we're always going to identify what is known. All right, there are 2 things given or known in this problem. We know the mass of the metal block, 402 grams, all right, and we know the volume, okay, the amount of space it takes up, all right, is 83 milliliters. Secondly, we're going to write down the equation that we can use to solve for the unknown. The unknown is density. We're asked to solve for the density of this metal. And we know that we can solve for density by taking the mass divided by the volume. All right, step 3, you're just going to show your work. You're going to plug those known items into that equation. All right, and then you're going to solve. Now, when you actually solve this problem, all right, 402 divided by 83, all right, does not get you exactly 4.8. It's actually 4.843373494 and so on. But what I want to point out here is that if we look at the problem, or what's known, the mass, 402 grams, has 3 significant figures. The volume, 83 milliliters, only has 2 significant figures. Therefore, our answer can only have those 2 significant figures. All right, it can't have 3. That's all the precision we can have. So that's just a little bit of the application of things that we've done up to this point. All right, let's try another one. A metal block has a density of 2.01 grams per milliliter and takes up a space of 36 milliliters. Determine the block's mass. Okay, again, problem solving steps. What do we know? We know its density. We know its volume. All right, what equation can I use to solve for the unknown? I need to solve for the block's mass. Well, mass is density times the volume. I'm going to take those 2 items, plug them in, and in this case, you can see that we have milliliters on the bottom of this one and milliliters over here. Well, those milliliters will actually cancel out. That will leave us only grams, and it works out to be, again, 72 grams if we consider we can only have 2 significant figures, because the density has 3, volume has 2. So we can only have 2 sig figs in our answer. Going to do one more. All right. Human has a mass of 50,505 grams. All right, and a density of 0.95 grams per milliliter. How much space does the human take up? All right, again, we write down the things that are known. Mass is given. Density is given. All right, what equation will allow us to solve for what's unknown? We're asked to solve for how much space. All right, space is a volume question. So volume is mass over density. Plug in my numbers. 50,500 grams divided by 0.95 grams per milliliter. Again, those grams will cancel out, and the milliliters are all that's left. And it works out to be 53,000 milliliters. Again, we can only have two significant figures on that because the 0.95 only has two. And that's how you do an example for any of the density, mass, or volume questions you might have in the assignment. Good luck.